All right, everyone, let's get started. Hang on one sec. Okay, so welcome to CS685 Advanced NLP. My name is Mohit. I'm a faculty member here at UMass researching in NLP. And this semester, we will focus our topics largely on recent developments in large language models. Most of you have probably played around with things like ChatGPT. And so this semester, much more so than previous semesters, we will first build up to explaining how a model like that even works, and then dive into some research around how we can improve it in various aspects. Okay, so before I jump into these slides, I just wanted to ask the YouTube audience, all 16 of you, if you can hear and see my slides, please just put something in the chat box to acknowledge that you can hear me. I will continue in the meantime. So first, some logistics stuff. So anyone here can feel free to attend the class in person or watch online via YouTube. The lectures are live streamed, and you can also watch them whenever you like after the stream has ended. So in terms of assignments, there will be 3 homework assignments. There will be weekly quizzes, not this week, probably starting next week. And those are usually released on Monday and due on Friday. So they're normally like very short, maybe 1 or 2 questions, free response. They're not graded for correctness. So that doesn't mean you can just write whatever you want, but you should, don't be afraid to make mistakes. We will be using Gradescope for all assignment submissions. I haven't yet set up the Gradescope, but you will all be invited to that probably later today or tomorrow. You actually have your first assignment released already, Homework 0. It is due not this Friday, but next Friday. It's actually very straightforward. It should take you maybe like half an hour or an hour to do. The reason why it's due next Friday is because there's all the stuff with ad drop and people switching in. So I want to give people enough time to do it. Okay, so let's get to the course staff. So we have 3 TAs this semester. The class is actually quite large. There's about 170 or something of you enrolled in person, and then there's also an online only like master's student section. So altogether it's close to 200 people. So the TAs are all NLP PhD students or are doing NLP research. They will be very useful for you in terms of your final projects in particular, to mentor you and make sure that whatever you have proposed and whatever problems that you're having can be resolved, and that you're not just going off on a track that will cause you to get a bad grade at the end of the semester. So 2 of the TAs are here. I'll ask you to just stand up and wave, I guess, so people know how you look. So this is Ankita and this is Yishao. And if you go to their office hours, you can talk to them about assignments or projects or whatever you would like. Okay, one other important thing is that if you ever have a question and you want to email or get in contact with any of the course staff, please do not email any of us directly. Use the instructor's account over here. This is the main method for communication between you and the course staff. And also, of course, there is a Piazza forum that all of you should have access to at this point. You can also post private or public messages there, and we will respond whenever we have a chance. Finally, the course website is very important. So if you want to see what readings or what topic we're going to be discussing for the next class, you should go to the course website, always refresh it. The slides for today and in the future will be posted probably right before class starts. So if you want to write stuff on the slides as we go, you can do that. This class is not all slide based. The initial couple weeks we will have some slides, and then towards the end of the semester we will be doing stuff on the iPad, and I'll put notes out after the class based on what we go through during class. Okay, and finally, if you are interested in just the general NLP research that's going on at UMass, you can check out the nlp.cs.umass.edu website for recent papers and topics and things like that. All right, so I won't hold the TAs too long. You can leave whenever you have a chance. Actually, maybe stay for this. So we do have office hour coverage 4 out of the 5 days of every week. So Yichao's and Ankita's and Yape, the other TA who couldn't be here, all will have office hours in CS207. So this is in the CS building. Mine will be in my office, CS258. These are all 1 hour long slots on normal weeks. The week before the exam or before some particularly challenging homework is due, we may extend those to 1.5 or 2 hours if needed. But there's a lot of office hours, so if you need help, you can get it in person as well. I'll also note that all of the office hours will be hybrid, just like this class. So all of us will have Zoom open along with taking in-person students. It is kind of annoying to manage, but we will do this. So the Zoom links for people who want to join the office hours remotely are on Piazza. They won't be shared anywhere else. So if you want to join office hours via Zoom, just look on Piazza and one of those pinned posts for the link on how to join each of these 4. Okay, any questions to this point? Great. All right, now you can leave. Okay, so we have been getting a lot of emails about waitlist, override, pass-fail. Sorry, not pass-fail yet. I'm sure that'll come eventually. We don't know how to handle these things. It's not our responsibility. If you are currently not enrolled in the class and you want to be enrolled in the class, there's a very long wait list. You can contact Jess or Christine Holbrook if you have any questions or requests, but it's not in any of the course staff's hands. So there are these add-drop deadlines that are different for grads and undergrads. This course, I think, is almost exclusively graduate students. So February 21st is the deadline that you should keep in mind for the add-drop deadline. All right, so sometimes people want to leave feedback on the course outside of Piazza or the email. We also have this anonymous Google form. If you want to leave any sort of critical or nice feedback, either is fine. Feel free to drop it in this Google form. We will go over some or all of the submitted responses for that week at the start of every class. I don't know why this is a sub-bullet here, but some frequently asked questions. Does this course require prior knowledge of NLP? Nope, it does not. However, basic machine learning, probability, stats, and obviously programming will help a lot. If you don't have background in any of these areas, you will need to study on your own to get up to speed. Also, homework 0, which is the first homework assignment already released, if you have any trouble with any of those questions, then you should study up on that topic to make sure you're familiar with it for the rest of the class, because otherwise it will be kind of a struggle. The class moves at a fairly fast pace, so you don't want to fall behind. I already talked about the notes, so I'll skip over that. There are no official prerequisites, but a little more specifically, we will be doing a lot of programming exclusively in Python, and some of the homeworks will use PyTorch, which is a deep learning library. So you don't need to know how to use it beforehand, but you may have to do some learning on your own to figure out how to actually implement the homeworks. We will be doing some matrix calculus when we talk about things like backpropagation. So you should be familiar, or at least willing to learn about that, and simple things like taking derivatives and all of these things. So yeah, again, please brush up on things as needed. Okay, so more admin stuff regarding grading. We have these weekly quizzes. They will account for 5% of your total grade. So I'm not sure how many of those we will have at this point, but cumulatively they will be 5%. There are tentatively 3 homework assignments planned for the semester. Each one will be worth 10%, including homework 0. So it's a pretty easy 10% here. All of the homeworks will be on Google Colab. So this is kind of like a notebook in the web browser that allows you to both write down your answers in free text, as well as write code and have it be run sometimes even on a GPU backend. Okay, so the exam, there will be only one exam. It will be in early April, probably, and because this class is like part of the enrolled students are remote, the exam will also be remote. It will be open book and internet. Unlike previous years where we used to give people 48 hours to complete the exam, now we will give you a maximum of 3 hours to complete the exam. This is partially due to AI things like ChatGPT, where, as you'll see later, can solve many of the previous year's exam questions. So, you get a little boost from ChatGPT, but you also get less time to complete the exam. So let's see how it goes. Finally, we have most of your grade will be based on the final project. So this is a project-driven class. You will be forced to divide up into groups of 4. You can choose any topic that you want, although you will get feedback on these topics from the TAs and myself. And then there are only 2 deliverables associated with this project. There's the project proposal, which is due in, I think, about a month. And that's the first, you write about 3 pages on any idea that you want. At this point, you won't have full knowledge of like all the technologies and models and methods that we'll be talking about. So your proposals will, understandably be kind of primitive, but at least the idea is what we're kind of judging to see if it's feasible or not. We make this proposal due pretty early on because you really need a lot of time to work on your project. So even if you have like a small scale idea that's not fully formed, you can continue to think about it as you learn more things in the class and implement some more advanced methods towards the end of the semester. The final report, I'm not sure yet if we'll have any sort of presentation. We've kind of eliminated the presentation during COVID, so probably it will just be a report, but that is worth 30% of your grade. And we, as I'll talk about the project a little bit later, but we're mainly looking for effort in the project report, so that you've tried a bunch of things, that you've done a good job, scientific job at testing and evaluating and drawing conclusions. And most projects don't actually work. I mean, it's very hard to push the state of the art or something on a task, but you can still do a good job and a bad job. So the project reports are graded quite strictly. You'll also have to submit all of the code and any data that you collect during this process, and those will be checked too. Okay, any questions about grading? All right. So regarding readings, there's no textbooks for this class. This is a very fast-moving field, so all of the readings will generally be either from conference papers that have been published in the last couple years, and they're just PDFs, they're open access. They might also be from an online textbook that is freely available, so you don't have to buy anything to follow along with the material in the class. Okay, so I've taught this class 3 times before, and the videos and materials for all of these classes in the previous semesters are available. The exam solutions for all of these years are not publicly available. I will make them available in Piazza probably closer to the midterm date so you can study them. But the questions change every year. So this year in particular, they might be a little more difficult to due to things like ChatGPT. Yes?
I thought you taught it in the spring, not the fall.
Oh, good point. Yes, that should say spring 2022. And that link is probably also wrong. But nonetheless, the videos are up and the materials and slides are all there. Yeah.
Are you trying to make it more difficult to combat ChatGPT, or are you essentially saying we should use it because it will be more difficult?
Oh, it's a good point. So actually, one thing, let me just go to our course AI policy. I wrote this up last night. All right, so using assistance from AIs such as ChatGPT to complete your homeworks, quizzes, project, and exam is allowed, explicitly allowed. If you take advantage of any sort of AI assistance for any of these assignments, you will be required to submit all of the specific prompts that you used, as well as a description of how the AI helped or did not help you complete the assignment. You will see this if you open homework 0. The final cell in the notebook is an AI disclosure that has you actually put down all this information. Finally, because, just trying to jump ahead of the Piazza posts, this should go without saying, but please don't argue about your grades because the AI generated the wrong answer. If you are using AI assistance, you are also responsible for making sure it is correct, or at least that you perceive it is correct before submitting it. So, the ChatGPT is really powerful. I will do a demo later on in the class with my own previous exam question to show you that it is pretty good. It's also, it is pretty good, but it makes factual errors oftentimes, and for particularly complicated or questions that are worded in a particular manner, it may struggle. So a lot of this class is also, because you're going to learn how this model actually works and all of the different components that make it work. You'll also get an idea of where it fails and where it needs to be improved. And there is no defense, no reliable defense against students using ChatGPT. It's very hard to detect the usage of ChatGPT, especially if you're an intelligent student and you can get around these defenses very easily. So in my opinion, I think it's better to just embrace it, assume everyone is going to use it, and move on. Also, it will be interesting for us to analyze your AI disclosure and see which questions it actually works on, what kind of prompts you're using that you find helpful. It might even form a nice meta assignment in this class where you all get to analyze each other's prompts and find a good way to answer a challenging question using ChatGPT. Okay, any questions about this? Yes?
For stuff like GitHub Copilot, where you don't actually give it a prompt in order to analyze the file, what do you want it to say for the prompts that we give it?
So even in GitHub Copilot, you do give it a prompt in terms of the code that you've already written. That is the input to the language model. Of course, we don't want you to provide your entire incremental code up till that point. But generally, you could provide a few lines or something like that. Also, with GitHub Copilot, I would, okay, maybe I'll add a specific thing on here, but if you use it in the sense that you write a comment and you're like, write me a function that does X, Y, Z, then you can submit that. If you're using it like the autocomplete to autocomplete a line of code, that's not necessary. But yeah, this AI policy, of course, can be used for the coding parts of the homeworks as well. I'm actually curious to see if it is useful for the coding cells in homework 0. But yeah, we are talking mainly about things like ChatGPT and GPT-3, where you do provide an explicit prompt to the model to get the output. Other questions? So one other thing I want to emphasize about this is that we are explicitly allowing all of these kinds of AIs. There's no penalty for using one. Like, you could literally use it to generate the answer to every single homework problem and get 100, and that's fine. So we would really like you to complete the AI disclosure. It doesn't matter if you used it for the whole homework. Just be honest that you did use it. There's absolutely no penalty for doing this. In fact, we encourage you to do it. So just wanted to be clear. Okay, let me get back to these slides and also see if there's any YouTube questions. Okay, looks like there's no YouTube questions. All right, so I think that's it on the admin related stuff. So I will move on now to the topic of this course, which is natural language processing. So by natural language, we are talking mainly about languages that evolved naturally through human use. So, you know, any language that is spoken by humans, Spanish, English, whatever. We will also this semester talk a bit more about code generation. So programming languages are not natural languages, but we can apply a lot of the same technologies that have been developed for natural language to code. And it's actually a very interesting and exciting area. So we'll talk a bit more about that in this semester. Okay, so what does processing mean? That's a pretty vague term. It can mean basically doing anything computationally with text. Some examples are supervised learning. So if you're given an input text, you can map it to some sort of expected output. Unsupervised learning, where you learn some properties of a text without any labels. So this could be, for example, clustering documents into topics. That's a very common unsupervised setup. We will spend a lot of the semester talking about generating text. Generating text has kind of become the de facto approach in NLP to solve any sort of natural language processing problem. Including things that previously were handled differently, like text classification or machine translation or sequence labeling. All of these things are nowadays handled within a text-to-text setup where the text generation technology is critical to their performance. Okay, so first, just so that everyone is on the same page, let's take English as an example and just look at all the different ways, the units of the language that then make up English. So here, if we have the sentence, Alice talked to Bob, we can of course divide this into characters, right? We could divide it perhaps further into bytes if we really wanted to, but we'll start with characters. So we can split the sentence into characters. We can get a little higher level than characters, right? We can look at these different subwords. So this ed suffix, for example, this indicates that this is a past tense verb, right? And talk here, the stem, has some semantic meaning, right? It indicates the act of talking. So talk and ed are two subwords that can combine to form the past tense verb talked. We can continue this segmentation at the word level, right? So at the word level, we can just split on, say, space here. It's a little more complicated than that, but in general, you can split on spaces. Each word carries some semantic meaning that contributes to the overall meaning of the sentence, right? So how do we combine words into sentences, and how do we combine sentences into paragraphs, into documents, and so on? Well, we use syntax, right? So syntax gives you the grammatical rules of the language. It tells you, for example, at the word level that talked is a past tense verb, and to is a preposition, and period is a punctuation, right? All of these are different roles in the language. You can also parse this sentence into a tree structure that tells you how the different units of the sentence are combined together to form one sentence level meaning here, S. So you can see if you look at this tree that this sentence S is divided into a noun phrase and a verb phrase. The noun phrase just includes Alice. The verb phrase includes talk to Bob. And you can see that the verb phrase is itself divided into this past tense verb and this prepositional phrase, which then down this hierarchy, you see the preposition and the noun. So this is a simple parse of this sentence that shows you the rules that are used to combine all these words into a single sentence. However, this doesn't tell you anything about the meaning of the sentence, right? It just tells you how words are combined in English. So you could also have a semantic representation of the sentence that focuses more on the meaning of the actual sentence. So here you can see that there's some sort of formal specification of the sentence's meaning. There's a communication event, and Alice is the agent of this event. Bob is the recipient of this event. There's a temporal aspect of the sentence in that it happened in the past, right? So you can encode all of these things into some sort of formal representation like this, and hopefully your representation here is expressive enough to cover the meaning of all sentences in the language, although this is very difficult. And so a lot of the things that we talk about in this class are related to coming up with semantic representations that are not explicitly structured like this, but actually learned by a very large neural network model. And finally, we can talk about discourse, which moves beyond sentences and looks at how the meaning of multiple sentences can arise in things like paragraphs or documents and so on. This is even more complicated. It's much more difficult to even come up with some sort of representation, structured representation of discourse level meaning. But we will talk about this again later in the semester. Okay. So that was just a quick introduction to the different levels of the linguistic hierarchy. Now I'll talk more about the processing side of NLP. So we'll start with probably the simplest case of supervised learning. So if you've taken any sort of machine learning class before, or if you've ever tried it yourself, you've probably encountered supervised learning, right? You have some data set of inputs and outputs. You have hopefully enough data that you can train a model to predict these outputs given the inputs in your training data, and then hopefully the model can generalize to some held out test data, right? So supervised learning was the dominant paradigm in NLP research before like 5 years ago. So what people would do if you wanted to solve, say, sentiment analysis. Sentiment analysis is a task where you're given some text of, say, a movie review or a restaurant review, and you're trying to predict whether that review is positive or negative. And so one thing that you can do to solve this task is crawl a huge set of reviews from somewhere like IMDb or Rotten Tomatoes or Yelp. You already have a lot of reviews paired with the score that the author of the review gave that text, right? So you can train a model directly on these reviews for the task of, given the review, predict the score. And if you have enough reviews, you can hopefully handle enough edge cases that come up in these kinds of review texts. Like, for example, what happens if you have a negation, like this food was not bad, right? Not bad does not mean it was good, right? But it doesn't mean it was bad either, right? There's a nuance there, and you have to consider it properly. And there's also many other things that come up that maybe like idiomatic language or references to pop culture. These are all things that the model has to learn just from its training data. So yeah, as I mentioned, many tasks were solved via supervised learning. The process is you collect a data set, you train a model on that data set. The model cannot do any task other than the one that it was trained on. So if you have a model that you trained on sentiment analysis, you can't use it for machine translation. You can't use it for question answering. It can only do sentiment analysis. So this is a very big limitation. Okay, so around, say, 2018, this new term, self-supervised learning, started to catch on. And it was mainly driven by a lot of the limitations of the supervised learning paradigm. So it's very hard to collect a lot of labeled examples for every task that you can imagine. People are trying to think, well, how can we do a good job to train a powerful NLP model without access to huge amounts of labeled X-Y pairs? And one insight was that you can get a lot of the way there with just text alone, unlabeled text. So imagine you have a dump of the internet, right? You have trillions, or I don't know how many words there are on the internet, and you train a model on that dump. Like that model has access to a lot of information. It may not be specialized to your particular task, but in that dump of the internet you have every single review written and posted on the internet. You have a lot of translated text that people have posted on the internet. You have a lot of questions and answers that people have posted. So perhaps a model that is trained on such a huge amount of data will learn to pick up some of these tasks by itself without requiring you to go out and curate the data yourself. So the core task of self-supervised learning in NLP is called language modeling. This will be the focus of our entire semester starting on Wednesday. So in language modeling, the task is very simple. Given the beginning of a sentence or a document, your task is to predict the next word. So I could give you a sentence like, Bob went to the restaurant and ordered a blank. And the task is for the model to predict which word goes into that blank, right? So even this very simple example shows you how powerful the task actually is. So for example, if you have Bob went to the restaurant and ordered there are now lots of constraints on what that word can be, right? It has to probably be some sort of edible item unless Bob is ordering some weird thing for no reason, right? It should probably be a food item. It should probably be a noun, right, in terms of the syntactic roles that we've been looking at. It wouldn't really make sense for Bob to order some sort of preposition, right? That doesn't really make sense in that context. So you can see that just this one context requires the model to have some actual semantic understanding about what a restaurant is, what kinds of things are offered by restaurants that could be ordered. And also it requires the model to understand some parts of language, right? You need to understand that after you see the phrase ordered a, you're likely to see a noun in the next word and not like a verb or something else. So you can take this simple example and then scale it to the entire internet. And now you have so many situations where world knowledge is needed or complex reasoning is needed. You can even include all of GitHub as part of your data. Right now, all sorts of complicated coding, everything is required for the model to make a good prediction of what the next word is. And so what we've generally found is that these self-supervised models are very capable of solving many different tasks without any sort of additional supervised training data for, say, sentiment analysis. So this question down here, how much data can we gather for these tasks? It's limited by how much data is available electronically the publicly accessible data. So homework 0 links you to the Common Crawl, which for those of you who are not familiar has just been crawling all of the web pages that are put on the internet for years. And so you have this enormous dump of text that you can use to train one of these language models. And in fact, companies like OpenAI and Google have been using for a couple of years now to train their models on. Okay, any questions on this? Okay. Another important paradigm that we'll see on the processing side is transfer learning. So one thing I forgot to mention here is that when we're doing self-supervised learning, we are generally doing what's called pre-training. So we have a model, we're pre-training it on unlabeled text, but our intent is to use this model to solve a variety of more specialized NLP tasks like sentiment analysis or question answering. So in transfer learning, we are going to first pre-train a model on a task like language modeling that's self-supervised. And then we are going to fine-tune this model in a supervised manner on whatever task that we actually care about solving. So for example, I can pre-train a large language model on hundreds of billions of words. And then I can fine-tune this model. So I can take my labeled data set of 20,000 reviews from this slide, and I can adjust the parameters of my language model such that it better solves this task of sentiment analysis. So the key difference here is that in this slide, my model is starting from scratch. Like, it has no information about language. It has no information about the task of sentiment analysis. It learns everything it knows about language and sentiment from this data set of 20,000 movie reviews. Of course, it's probably not good to learn an entire language from just 20,000 movie reviews, right? And so in transfer learning, the model that you start with is pre-trained on this general purpose task of predicting the next word. And only when it gets to a reasonable ability of predicting the next word do you then repurpose it for solving this sentiment analysis task. So this kind of specialization phase where you take a general purpose model like a language model and you specialize it to something like sentiment analysis, that is called fine-tuning. And this was very popular for until like even earlier this year. This was generally how people reach state-of-the-art performance on many different natural language processing tasks. However, now in the last few months, it's becoming increasingly clear that prompt-based learning is a very strong competitor to fine-tuning, and it has many advantages. So in prompt-based learning, you do the initial pre-training task, but you don't do any further specialization of this model at all. There's no fine-tuning. Instead, you come up with ideally some sort of natural language prompt that guides this pre-trained language model to solving the task that you want. So let's continue with our sentiment analysis example. So here, we're going to pre-train our large language model just like in this previous slide. But here, we are going to feed in, instead of doing any sort of fine-tuning, we will just say, what is the sentiment of this sentence, and insert the sentence, and then hope that the language model generates a positive or a negative score that corresponds to that sentence. So this kind of prompt-based learning requires a very, very powerful language model that has at least some like rudimentary understanding of the instruction that you're giving it, and can also reason over this prompt in order to learn what you want it to actually do. So in some sense, you're like telling the model, this is the task I want you to solve. I'm not going to actually update your parameters at all to solve this task. You figure it out and do it yourself. Yeah.
Yeah, I was just sort of confused too as how prompt-based learning would then factor into the actual training and like making of language models and questions. It seems almost like That's semantics of how you deliver the task you're trying to perform, as opposed to how the model actually works. Like, it seems meta in a sense, and not relevant to data.
Yeah, so that's a good question. So I'll just repeat the question for the YouTube audience. So the question was essentially like these instructions that you're feeding into the prompt to solve a particular task, they're kind of unnatural in a way, right? The model is not trained specifically on these different kinds of instructions, so how can it then generalize and solve all of these tasks while it might just be trained on sentences like Bob went to the restaurant and ordered a blank, right? So there are a lot of other techniques that go into specializing a language model for prompt-based learning that I haven't mentioned here, but we will cover in the slides. There are things called instruction tuning. There's you actually can fine-tune the model on many human-written prompts and outputs to kind of guide the model to, you know, be more amenable to receiving these instructions in whatever format you have. There's also a lot of human feedback tuning involved in making these models kind of adapt to what you as the end user would like it to do. There are many other techniques that we'll talk about later on in the semester, but broadly you get a lot of the way by just pre-training this language model. If you imagine the entire internet, there are a lot of instructions followed by example outputs. It's hard to even imagine what is on the entire internet, but there's a lot of this kind of language that helps the model kind of follow along with whatever you're saying. Yes?
So they are actually training the model to solve a particular task. So generalized model and whatever task needed solved will answer them from prompts.
Yeah, so the question is, like this language model is not trained to solve any particular NLP task, and the prompt that we feed it is actually kind of telling the model to specialize its output to solve a certain task in natural language. So I will clarify though that the language model is trained for a very specific task of predicting the next word. These properties, such as the ability to follow instructions to solve various tasks, kind of emerge as that language modeling task is scaled up to larger and larger amounts of text, and with a model that is powerful enough to actually solve this task to a reasonable degree when confronted with such a huge amount of text. So if a lot of this is confusing, this is also the main topic of this course, so we'll talk about the details in subsequent lectures. Yes? The question is prompt-based learning supervised? No, so there's no, learning here is actually kind of misleading in that the model is no longer updated after this pre-training stage. The prompt is just a text-based instruction that you as the user of this model come up with, pass it into the model and see what it generates. So the model is not being updated during this process. Although there are methods that do update the model during this process, which we will discuss also, but at least in something like ChatGPT, the model is not actually learning from your input the moment that you type it in. It is updated much later on in a batch on many different users' inputs, but it's a fixed model. Like if you use ChatGPT now and I use it and we type in the same input, or we type in different inputs, the same exact model parameters are used in both cases to generate the output.
Does the data on which the model is pre-trained determine which prompts will or will not be successfully answered?
Yeah, this is a great question. So the question is regarding, does the data that the model is pre-trained on affect its ability to work with prompt-based learning? The answer is yes, but we don't know yet how exactly. We do know that the scale of the data matters a lot. So if you have a lot of data, like hundreds of billions or up to 1 trillion words, you will get some of these properties emerging compared to if you only had, say, like 1 or 2 billion words. But it's very difficult to know exactly what content of that pre-training data makes this kind of property emerge. So it's very difficult to do experiments like that because only a few industry labs have the scale to even begin to answer that question.
So like as a thought experiment, if you take that dev corpus and filter out for the word sentiment and just remove it from your K10 data, will you be able to, I don't know, does intuition say that you will be able to answer this prompt? What is the sentiment of this sentence?
That's a good question. I think that's a lot harder than you imagine. Even if you filter out that word, you would actually have to filter out probably every single word that contains any sort of sentiment in order for it to work like this. Yeah, so, but, you know, something that we can't actually do. There was another question over here. Okay, and I see there's one on, oh, there's a couple on YouTube. How is sentiment analysis reducible to text generation? So on this slide, you can see, I can say, what is the sentiment of this sentence, insert the sentence, and then in order to solve sentiment analysis, the model needs to indicate whether the sentence is positive or negative. So a very simple way you could reduce this to generation is to make the model generate the word positive when the sentiment is positive and generate the word negative when it's negative. So in supervised learning, your model can only tell you whether something is positive or negative. If you treat this as a generation problem, your model is capable of solving a whole lot of other tasks, including but not limited to sentiment analysis. So this is a huge advance because you can use the same model for many different things. How, there's another YouTube question. How can large language models be used in healthcare where specialized knowledge will be required? This is something we'll talk about more towards the middle part of the semester. There are many methods to, that involve specializing these models to a particular domain. You can do additional pre-training on text from that domain, or you can, essentially all of them amount to modifying the data that the model is trained on. All right, so ChatGPT, for example, is using this kind of prompt-based learning on when you interact with it, your inputs are prompts and the model is generating outputs to that. Yeah, last question on this.
Yeah, so for every language model, we have some limit on the number of tokens. So we have like tasks which require longer amount of prompts, and how do we do it?
Yeah, so the question is, what if your language model, so all language models have a fixed number of words that they can process at any time. What if you have a task that requires more than that number of tokens? We'll have a couple lectures on this. So there are many methods that have been developed to handle this kind of situation. There's modifications of the language model architecture, like more efficient transformers. There's also more efficient ways in which you can use the transformer on such a long text. So we'll talk about that.
I was asking more in the context of prompting.
Of prompting?
Yeah.
I mean, I think the answer still applies. Like, regardless, you will run out of tokens in your context, and you have to have a solution for dealing with that. So I don't think the method actually changes depending on if you're using it for prompting or fine-tuning or any of these different cases. Okay, so let me just move on in the interest of time, because I do want to show some demos. Here's a rough list of topics. If you notice, it is quite similar to what was taught last spring, but probably the second half of this semester will be quite different in terms of more advanced topics that we cover. So the initial couple weeks here will focus on the task of language modeling, neural networks and applying them to language modeling. We'll then cover a bunch of neural network architectures with a focus on the transformer, which is the one that is used today in things like ChatGPT. Then we'll talk about applying these kinds of models to different tasks, how we create data for these tasks and evaluate the outputs. Any ethical issues, obviously there are several in ChatGPT, including how they are used in courses. And finally, and this is the second part of this semester, we'll mainly focus on very, very new methods that have recently been released, like this year, to improve over different aspects of prompt-based learning. All right. So I just want to, before I do some demos, talk in a little bit more detail about your final project so you have some idea of what to expect. And then, yeah, we'll do some demos. So as far as the timeline goes, first, again, this is a group project. We are not going to allow individual projects. There's just a huge class. So you're going to have to form into groups of 4. You can do that either yourself if you have, 4 people, 3 other people that you want to work with. If you don't, we will randomly assign you to a group by February 17th. On Piazza, there's a search for teammates form or post that you can use if you have a specific idea or subfield that you want to do a project on. You can find like-minded people to join your group. I would highly encourage you to start using that ASAP so you can form your team by next Friday. Also, for those of you in the online-only section, you will form groups amongst yourselves, so not with the in-class people. So we will email you separately about that. Yeah, as I mentioned before, there are 2 deliverables. The proposal is 3+ pages. The final report is 8+ pages. The details about both of those things will follow. And there's no recommended project topic. So what we do encourage you to do is read some NLP papers, try and get a sense of what topics you yourself are interested in, and try and do a project around that. Homework 0 contains a problem that requires you to find an NLP paper that you think is interesting and summarize it. So that'll also give you some experience in finding these research papers and reading them, and hopefully getting some ideas or inspiration from those. So that said, there are some basic things that you need to keep in mind. So all projects obviously should involve some sort of natural language data like text, or it could involve code generation as well. There should be some significant coding component of every project. I think that should also go without saying. Even if you're doing more of an evaluation or data collection project, you still need to do something with the models that we're discussing in this class. All right. So as I mentioned, there are many different types of projects. So you could, for example, create your own data set for a specific task that you think doesn't exist already in the literature. You could build a new model. You could work on making a new modeling advance or contribution that hasn't been done before. You could do a replication study of maybe there are a couple of different models people have proposed on different tasks, but they haven't been compared head-to-head together. If you do a replication study, you have to write the code yourself for all of the models that you're replicating. So you can't just say, I'm going to take these 3 GitHub repos and run all of them, and then that's my project. That's not going to get you. I mean, many people have done this, and they're graded accordingly. All right, so yeah, we are very open to the type of project. So not all of your projects have to be on some sort of new model. Even nowadays, things like evaluating new tasks are equally or even more important than the models themselves. So as we'll see in this class during this semester. So you can think creatively about what might be a good project. Okay, so when you're writing your proposals, as those are due in a month, you're going to have to answer some questions like, what is the question that you are studying? What is the research problem here? What has been done before on this problem? And what is motivating you to work on it? What experiments do you think you will do? And what do you hope that they will tell you? And how will you evaluate your experiments? So again, just emphasizing your project does not have to work for you to get a good grade. So if you propose in your proposal that you will get like state-of-the-art accuracy on some data set and you don't actually get that, but you do a very strong error analysis to show what your model is still struggling with, and explain what you think needs to be done to get to that point. That is also acceptable as long as you clearly put in a lot of effort to getting to that point. Yeah. Finally, on this, what I wanted to say is that NLP research is all open access. All the best NLP research is freely available on the internet. You'll get a chance to interact with this ACL anthology in Homework 0. It basically contains all the top published papers in this area. You can also read NLP-related papers from machine learning conferences. I've listed some of them here. If you want even more recent cutting-edge developments, you should check out Archive, which is where most NLP papers are first posted before they're eventually published. And these papers are also often discussed at length on Twitter. If you really want to follow along, I would recommend following some NLP researchers on Twitter to get a hang of like what are the actual things that people right now are interested in. If you're searching for papers, you should use things like Semantic Scholar and Google Scholar. Look at, use some keywords, find a paper you like, look at the papers that paper cites or that are cited by that paper, and kind of expand your reading that way. All right. This will be in the Overleaf template. By the way, all of the project-related things will be done on Overleaf using LaTeX. So if you don't know how to use LaTeX, you will learn during this process. There will be a template posted for both the project proposal and final report that we expect you to follow. All right, so I'm going to skip over these project things and just one last time talking about these deadlines. Homework 0 is due February 17th. Your group assignments, if you want to choose your own group, are also due February 17th. And your project proposals due March 8th. So these are the three major-ish deliverables that you have over the next month. You will also have a couple weekly quizzes, but those are minor compared to these. All right, any questions?
How are we going to deal with the computational resources?
That's a good question. So how are we going to deal with computational resources? So in the past, we have strongly encouraged groups to use Google Colab, which gives you at least some access to back-end GPU. This semester in particular, I'm not sure what the best way will be for people to actually do large-scale modeling projects. I probably wouldn't recommend trying to train your own giant language model that, if you propose that, will instantly will tell you to do something else. However, there are easy ways to access these models via API. So for example, OpenAI provides an API to interact with even their largest models, and it's fairly cheap. And also ChatGPT, of course, is free to use as of now. It is very likely that they paywall it completely sometime during this semester, which would also be interesting for you all. Yeah, they should provide API access to that as well at some point. I would expect this semester probably more and more groups will be using API access to one of these large language models for their projects at some level. But yeah, I would recommend using Google Colab if you want to do any sort of small-scale training and things like that, so you don't have to worry about using your own GPUs. That's a good question. I see another question. Oh, there's several questions. Okay, I'm going to skip over these questions that were about the prompting. Is it okay to expand on our own prior research for this project? Yeah, that's totally fine as long as you can convince 3 other people that your prior research is interesting, and also convince us that there's a lot of work left to do. All right, so for the first demo, it's not really a demo. I just wanted to show you the Hugging Face website. So Hugging Face is a library that hosts many different NLP models. You can see it's, I don't know if you can see this actually. There's 131,000 different models that people have trained for various NLP tasks that are all hosted on here. So for example, we see these are all like general purpose language models. You can sort by task also. So let's say we wanted to do, I don't know, text classification. So this is a sentiment analysis model. There's even a demo here on the side. So I don't know why this is the example. I like you, I love you. I assume it, okay, it says it's 100% positive. So if I said something like, I don't like you. Wow, okay, this is 99% negative. So like you can play around with these models on a Hugging Face. You can also download them. They have a very nice Python library that allows you to interact with these models. One of your homework assignments will have you downloading some of these models and modifying them in a Google Colab notebook. So highly recommend looking at this and playing around with some of the models for your project proposals to see if your idea is feasible or could be solved by some of these different things. Okay, so the other thing I wanted to do was look at ChatGPT and show you some of its abilities and some of its downsides. So I guess I should refresh here and just hope that it is actually working for this demo. They are experiencing obviously very high load, as probably like every student in the country is using it at this point. So if you haven't used this before, maybe I should do a poll. How many of you have tried this before? Wow, okay. It's like 90% of you. It's very capable at solving many of these different tasks. So anything that I input here is a prompt, right? So I could say like, write a short story about a CS685 student who uses an AI to complete all of their assignments. Hey, once upon a time, there's a student named Alex enrolled in CS685. They found their coursework to be quite challenging and felt more and more overwhelmed. Oh, wow, okay. So it looks like they purchased an AI. It was able to complete all of their assignments in just a matter of hours. The solutions were not only correct, but also creative and well-written. They had more time to focus on their personal life and hobby. However, as the semester progressed, Alex realized they were missing out on the learning experience. They had relied so much on the AI that they didn't understand the concepts they were being tested on. Despite receiving top grades on all their assignments, they felt like a fraud. Eventually, Alex came to realize that the true value of education comes from the process of learning and not just the grades. They made the decision to turn off the AI and complete the rest of their assignments on their own. Okay, wow, nice moral here. So, okay, it can clearly do these kinds of creative writing tasks to some extent. You can even use it to kind of rewrite or rephrase the text that has been written. So I could ask it, for example, to write this in a different style. Like I could say, I don't know what style. Maybe I'll rewrite that the above story in Twitter speak using emojis and slang. All right, let's see what happens here. Oh my God. I feel like it just is adding an emoji after every sentence. Oh, the grades were fire, but the wow, this is actually pretty good. Education over grades. That's fine. So you could see like some very legitimate use cases for this kind of thing if you, for example, are a non-native speaker and want to use it to like correct any grammatical errors or rewrite it to be more professional or whatever. Like this is very good, right? It could also potentially help people learning a new language and things like that. There are many positive applications of this technology. So some downsides, though, are that currently this AI is not connected to the real world, right? It doesn't have information about things that are going on right now. This is because it was pre-trained at some point in like, I don't know, June of 2022 or something, and it hasn't been really updated. Well, it has, but not to a large extent since that point. So I could ask it, what is the topic of CS685 at UMass? And it's really struggling here. I'm sorry. So you can see that it doesn't have the answer, but it still is producing some random stuff that is probably not helpful. I could ask it, other questions like this where it needs to interact with some real-time knowledge, and yeah.
What does it mean by January 30th version? Is that just fixing bugs or?
Oh, okay, yeah. So down here you can see the version, like when this model was last updated. So if you see here, you can either thumbs up or thumbs down this response. So I could thumbs down this response because it isn't helpful. And so this gives them some human feedback on whether or not this answer was actually good. And they can tune their model to kind of lower the probability of things that were downvoted and perhaps increase the probability of things that are upvoted through several different methods. So when they update and they say January 30th version, that generally means that they tuned their model on human feedback or on, so OpenAI has hired a lot of contractors that are solving various problems using this AI, so they're also providing feedback. Generally, this means that they haven't just completely retrained their model, they've just updated it using some human feedback. So they do this periodically, which is both good and annoying because if they update it the next day, it might spit out a completely different answer than what it did today. Okay, so, right. The other thing I wanted to do was paste in some of my exam questions to see if it solves them. So this is the exam from last semester. And I just wanted to show you what happens if you take the first problem here and put it into ChatGPT. So I'll just give you a very quick overview of this problem. This problem, this person, Gabby, is trying to build a text summarization system. So in text summarization, you have a very large document and you're trying to produce like a paragraph-long summary of all the important information in the document. So she's trying to build a summarization system for the Thai language specifically. So she is only able to collect a very small data set of 1,000 Thai documents and summaries. And essentially, the question is centering around the evaluation of her Thai summary system. So she's using an evaluation metric that is developed for English, which takes advantage of the fact that English text, the words are usually separated by white space, whereas in the Thai language, there is no white space tokenization of words. So the answer to this question is that she can't use the English evaluation because the Thai language works differently. Words are not segmented like they are in English. We'll go over this question in detail closer to the midterm, but I just wanted to show you what happens if you paste an actual like fairly complicated question into something like ChatGPT, and let's see if it actually gets it right. Okay, so it does understand LaTeX, which is nice. So I'll just paste this directly into here. and get rid of this. So I pasted this entire question into here, and let's see what happens. So again, the answer should say that Thai cannot be split, words in Thai cannot be split using white space, and therefore the evaluation metric cannot be used. You can see that it actually recognizes this. It says tokenizing Thai using white space, as Gabby did, may not accurately represent the structure of the Thai language, leading to mismatches between the generated summaries and the ground truth summaries. It also is producing a bunch of other text which may not be super relevant, but this answer would actually probably receive full credit if you had given it on last year's exam. That said, it really does struggle when you put in things that are more difficult. So I also tried the second part to this question, which is come up with a method that addresses this issue of the Thai language not being structured the same as English, with a particular constraint on how the method can work. So, whoops, I can just paste this into here. So this is essentially asking the model, asking the student to fix the problem that you just found in the previous question. And so here you can see that the answer that it produces is actually invalid in terms of what is asked for in the question. So it says you shouldn't use any external resources not mentioned in the problem statement, and the model says you should use human evaluation using human evaluators. Where are those coming from? It's very unclear. Like this answer would receive no points. And so you can see that there are things that the model struggles with in terms of both understanding the prompt and also generating a viable answer. It can perform fairly complicated reasoning, as you saw in this first question here, but it also can easily mislead you into writing an answer that is just not correct. Yeah.
I've noticed that sometimes when it gets it wrong, you can kind of ask it, hey, can you do it again, but don't include this, and it might get it right. So
Yeah. That is true, and I think the TAs will have a lot of fun rewording all the exam questions to make them at least somewhat hard to game. Yeah, I think, like, broadly speaking, the exam will kind of be adversarially constructed against at least whatever the latest version of ChatGPT is, such that all of its answers will hopefully be wrong. Hopefully for me, not for you. But yeah, it'll be a fun semester. So with that, I will see you on Wednesday when we will talk about language models.